Hey everybody! Today we're going to be talking about the gram stain and how we actually do the gram stain. So the gram stain is a very common differential stain that's used all the time. It's used for classifying bacteria, basically because the two major groups that we classify bacteria into is whether or not they're gram positives or if they're gram negatives. It's also used very commonly in medicine, as depending on if a bacterium is gram-positive or gram-negative, you're going to be able to use different antibiotics to treat it, or you might have different treatment courses for a specific patient based on whether or not, again, they're gram-positives or gram-negatives. So let's talk about the materials that we're going to need in order to do our stain. You are going to need a heat-fixed smear to do this, so make sure that the first thing you do is that you get your slide, get the water on there, get your sample in it, then let it dry, and then heat fix it so that your smear is ready to go. You're going to need a staining area, so again, if you have your little staining tray, that will work, or if you have the staining sink, that's what you're going to need as well. You're going to need some DI water for the rinses that we have to do in the stain, and you're going to need a paper towel or biblious paper, something like that, that we can blot with at the end. Now the last thing that you're going to need for our setup here, it is a multiple step stain, is you're going to need 4 reagents. So our primary stain is going to be crystal violet. Our mordant is going to be iodine. Our decolorizer is going to be ethyl alcohol. And just a heads up on the alcohol, if you have a staining kit that looks like this, you're going to have another bottle that says acid alcohol on it. Do not use the acid alcohol. It is different and it's used for a different stain. So you want to use the bottle that says either ethyl alcohol on it, 95% alcohol, or ETOH. All of those are common ways to indicate ethanol. So that's going to be our decolorizer, and then our counter stain is going to be safranin. So with all of our materials out of the way, let's go ahead and actually run the stain. So we're going to get our smear in place, we're going to get it on our staining tray, and then what we're going to do is we're going to start out with our primary stain, our crystal violet, and we're just going to flood the slide for roughly 30 seconds. So you want to make sure that you cover the entire slide. Now, just to kind of go through and talk a little bit about the stain and what we would expect to see at each step, basically, gram-positives, they have very thick peptidoglycan layers, and that's where our stain kind of likes to sit. Whereas a gram-negative, they have kind of thin peptidoglycan layers. So what happens at this point here is either way, a thick or a thin peptidoglycan layer is going to fill up with our crystal violet, and at this point, both gram-positives and gram-negatives would look purple if we were to look at them under the microscope. So I'm going to assume that my 30 seconds is up. I'm going to take and I'm going to tilt my slide kind of at a 45-degree angle. I'm going to take my DI water and I'm just going to rinse both sides of the slide real fast. Make sure that if you're rinsing the back that you keep track of what side is up. If you end up staining the back of it, you're not really going to see a whole lot. So make sure to always keep track of what side is up. Now next up, I'm going to go ahead and I'm going to add my iodine to it. And I want to add my iodine for roughly 1 minute or so. So again, I'm going to try and flood the whole slide here. All right. Give it one more here. It's not spreading very well. There we go. That should be sufficient. All right. So iodine again is our mordant, and the way that we kind of define a mordant is that it makes the primary stain stick. So what actually happens is in our gram-positive bacteria, that thick peptidoglycan layer basically shrinks down quite a bit, and it traps a lot of that crystal violet inside of it. In a gram-negative organism, since the peptidoglycan layer is really, really thin, there's not a lot of shrinkage, and because of that, the crystal violet is not really retained within that cell wall very well. So either way though, at this point, if we were to look at them under the microscope, they would still probably look purple. They might have a little bit of an orange tint because of the iodine, but they're mostly going to be looking purple at this point. So again, I'm going to assume my 1 minute is up for my iodine, and I'm going to just go ahead, I'm going to give it, a nice quick rinse, a couple of seconds there, give it a little bit on the back, and we should be good to go. Now, the next step is the decolorization step, and this is by far the most critical step that we have. Basically, if you decolorize too long, your gram positives will look gram negative. If you do not decolorize enough, your gram negatives will look gram positive. So this is the most critical step. And basically, the way that the decolorization works is that once we put the alcohol on there, the decolorization starts, and it does not end until we rinse it with water. So even if we stop applying alcohol, it's still decolorizing. So we want to decolorize for about 8 to 12 seconds or so. And then we want to immediately start rinsing. So I'm going to get some alcohol, and I'm just going to start here, just ever so slowly, just kind of letting it run down the slide. And that should be about 10 seconds or so. And now I want to immediately again start rinsing so that I am stopping that decolorization process. All right. So basically what that alcohol is going to do is that it is going to try and remove the crystal violet. So in our gram positives, because that thick peptidoglycan layer was shrunk down, it actually holds onto the crystal violet really well, and the alcohol is not able to remove it, so they're going to stay purple. Now in the gram negatives, because their thin peptidoglycan layer was not shrunk down, all of that crystal violet is going to be removed, and they're going to become colorless at this point. So let me just screw that on there real fast. Next up, again, we're going to counterstain with safranin, and we're going to just flood the whole slide with our safranin, and we're going for about a minute or so with our safranin in order to counterstain. Now, the goal with the counterstain here is that in the gram positives, again, they've been shrunk down, those peptidoglycan layers, they're packed full of crystal violet, so our red safranin won't be able to actually fit inside of those cell walls. But in the gram negatives, what's going to happen is, since all that crystal violet was removed from the thin peptidoglycan layer, now there's room for the safranin to come in there, and at this point, again, your gram positives should still look purple, but your gram negatives will now look more of a pinkish or a reddish color under the microscope. So again, we're going to assume our 1 minute is up. I'm going to go ahead, I'm going to rinse my slide. I'm going to rinse it on both sides real fast. Once I'm done, I want to go ahead, I'm just going to move this out of the way. I'm going to blot my slide. Remember, we always blot. We don't wipe the slide, we always blot it so that we don't wipe off our sample. But at this point, my slide is now ready to go, and I can look at it under oil immersion to see whether or not the bacteria that I have is gram positive or gram negative. So just to kind of show what that actually looks like under the microscope, here's a picture of that. And what you can see here is that some of these guys are purple, those are going to be your gram positives, and some of them are that kind of pinkish red, and those are going to be your gram negatives. But that should include what we need to know for the gram stain.